Assalamualaikum. We are from Group 1 of AS254M1 to present about the evaluation of respirable dust, silica, metal fumes, chromium, and also aromatic hydrocarbon silane. This presentation are prepared by me, Naziatul Amira binti Arifin, along with Fauziatun Nadira binti Hilmi, Nurin Hani Sofia binti Mat Naziron, and also Nur Kristina Izzati binti Shahril. For this presentation, we will analyze throughout the background of the study, methodology, and monitoring procedure, sampling techniques, monitoring strategy, sampling management, laboratory analysis, recommendation, and lastly, conclusion. So, for this study, the factory chosen is XYZ Scientific Resources Sdn Bhd, which is located at Free Trade Zone Batu Berendam, Melaka. A hygiene technician monitored this factory by personal exposure monitoring in order to assess the workers' risk of exposure within the breathing zone, which is commonly called or lapel. This monitoring is performed for a specific time period, which is 8 hours of working shift according to the usage regulation, which is use and standard of exposure chemical hazardous to health. The monitoring is performed at 10 April 2024, and there are 3 selected monitoring areas, which are firstly, chemistry laboratory, which handles the aromatic hydrocarbon silane during the printing process, environmental laboratory, where the worker conducted a waving process of respirable dust, crystalline silica, and lastly, physical laboratory, where the workers handle the metal fumes, chromium. All these 3 laboratories operated on 8 hours working shift starting 8 AM onwards until 5 PM. A hygiene technician monitored this area and selected high-risk workers to assess engineering controls and several other methods for the occurrence of the chemical exposures that is hazardous to the workers.
Next part is walkthrough and visual inspection. For the working process in an environmental laboratory, Mr. Ali was exposed to hazardous substances, which is crystalline silica, due to inhalation exposure in the air. He wears latex gloves and conduct the process in a fume hood with adequate ventilation to ensure a good flow and control chemical exhaustion. But he's not wearing proper personal protective equipment, which is safety glasses and fitted masks. For the painting process in the chemistry laboratory, Mr. Ragu was exposed to toxic substance, which is xylene, due to dermal exposure. He wears proper personal protective equipment, which is Tycan suit, latex glove, and N95 mask. However, he's not wearing safety glasses that can contribute to chemical contact to the eyes. For soldering process in physical laboratory, Ms. Lee was exposed to hexavalent chromium due to inhalation exposure. This process involved melting the solder, resulting in the release of chromium vapor. She's not wearing a proper PPE, which is safety glasses, suitable mask, safety shoes, and conductive gloves. Latex gloves are not appropriate to protect skin from hot and water metal. Next part is air monitoring procedure. First is sample preparation. A preliminary inspection was carried out. Large method used by IR spectrometer, SKC HXR 5000 pump, and Defender 530 Pro calibrated. 5 micrometer filter and cycle was prepared. For taking sample, sampling instrument and selected worker were assembled and with the monitoring purpose. A sampling device mounted on the worker, then the pump started and record the time. During sampling, flow rate pump sampling device and sample were checked. The work routine and effectiveness of control measure were observed. End of sampling, the sample pack collected by industrial hygiene for analysis. Then, to analyze the sample, the filter was conditioned before weighing process. The amount of sample and air sample was determined. Contaminant concentration was determined by using blend correction. Calculated TWA was compared with PEL.
We used the NIOSH method and a sampling pump of SKC AirCheck XR5000 with a high flow for respirable dust, silica amorphous, low flow for aromatic hydrocarbon, xylene, and high flow for metal vapors, chromium. The sampling media used is respirable dust, silica amorphous, aromatic hydrocarbon, xylene is solid sorbate tube, coconut shell charcoal 100 mg per 50 mg. The metal vapors chromium is 0.8 micrometers MCE filter, and the calibrator is Defender 530L low flow. The selection of workers need to be selected in order to get the highest exposure from a group of workers doing a similar job at the same work area based on the factors of nearest to the source, duration and frequency of exposure, nature of work and work practice, and also the availability of control measure. These are the monitoring period and number of shifts for each work specification for Mr. Ali, Mr. Ragu, and Ms. Lee. Mr. Ali from 8 AM to 5 PM, Mr. Ragu 8 AM to 5 PM, and also Ms. Lee is the same time. We have 2 types of monitoring, which is personal monitoring that represent employees for a similar exposure group as EG and conduct for a specific period of 8 hours or 15 minutes. This must be observed due to the variability of exposure and pump failure. This figure shows the sampling medium is positioned in worker's breathing zone, so the worker can move around while working and the sampler constantly captures sample in air breathing zone. Also, the battery-operated air pump is placed on the person's belt and clipping a collection tube or filter cassette near the collar. A worker's breathing zone is a hemisphere with a radius of 30 cm that extends in front of the face. This zone defined as the midpoint of an imaginary line connecting with ears. The second one is the area monitoring or source sampling is to obtain information on the likely sources contributing to the exposure. Ensure that no settled dust or chemical spills are too close to or directly in touch with the sample collection medium. As extent control measure, which is engineering controls, it is a process or equipment that can minimize the generation of hazardous substances or which to limit the area of contamination in the event of spills or leaks. Here are some examples of engineering controls. In the environmental laboratory, it contains a fume hood that is used for handling volatile chemicals. It effectively prevents direct exposure to the worker to fumes by drawing them upwards. And for the physical laboratory, it is equipped with air conditioning, which guarantees adequate air circulation in space. Since air conditioning units typically come with dust filters installed, this could contribute to the lab's clean and safe air quality.
Assalamualaikum and hi, my name is Nur Christina Izzati binti Sahil and I will explain regarding sampling management for general controls. For the environmental laboratory, the general controls are PPE and training. For the PPE, Mr. Ali was seen wearing medical grade masks instead of N95 respirators, latex gloves and fully covered shoes. And we need to ensure that Mr. Ali is trained on the hazards of crystalline silica and proper handling techniques. For the chemistry laboratory, proper storage of paints is crucial in reducing the risk of fire or chemical exposure, and readily available spill kits equipped with absorbents and neutralizers are important to manage accidental spills. Lastly is physical laboratory. The general controls are PPE and training. Miss Lee was seen wearing medical grade mask and glove, and we need to ensure Miss Lee is trained on ergonomic practices and proper use of tools. The next part is the laboratory analysis, which consists of sampling result management as well as the calculation. The first sample of interest is respirable dust, specifically crystalline silica. So from this data, we can calculate the exposure limit or TWA. The formula for 8-hour TWA is concentration multiplied by the time from addition of all sample and divided by the total time, which is 480 minutes. So, the exposure limit that we get is 1.5925 mg per cubic meter. Besides, the permissible exposure limit for crystalline silica is 0.05. We can conclude that the value of TWA is more than PEL. The next sample of interest is xylene in the chemistry laboratory. The TWA that we get is 268.1438 mg per cubic meter. The permissible exposure limit for xylene is 434, so the TWA is less than the PEL. Since 268.1438 8-hour TWA is less than 434 for PEL, the exposure for xylene is acceptable. Last but not least is chromium fumes. The calculated TWA for chromium is 0.1475 mg per cubic meter, so you can conclude that the TWA is more than PEL. Since 0.1475 8-hour TWA is more than 0.005 PEL, the exposure for chromium fumes is not acceptable.
So, based on the several issues and problems that happen, there are a few recommendations that we may give. We'll start with the aspect of engineering control. So, firstly, we have isolation, automation, barriers, and dilution. So, for isolation, we can isolate the hazard for a certain period of time. For instance, installing an insulated and air-conditioned control room may protect operators or workers from the toxic and hazardous chemicals. For automation, we may allow computer control robots in order to handle the dangerous process such as spot welding operation in car plants to protect workers from the robotic hazard. And thirdly, we have barriers in blocking a hazard before it reaches the workers by installing special curtain or barriers that may prevent eye injuries or respiratory issue from welding out radiation. And lastly, we have dilution, where the ventilation systems are installed because they may dilute or dissipate toxic gases before they reach operators and workers.
The second recommendation is administrative control. Some of the practices that can be implemented are supervision and training, which to provide the workers with appropriate supervision to help them identify potential hazards. Secondly is job rotation, which to prevent the period of risk exposure and cumulative trauma injuries. The next one is housekeeping, repair and maintenance. Housekeeping involves cleaning, waste disposal and spill cleanup. Maintaining cleanliness will prevent the accumulation of chromium dust and residues. Lastly is hygiene. If it is possible, it should be mandatory for workers to change into new clothes and take a shower once their shift is over.
The last recommendation is personal protective equipment (PPE), where every employees are required to wear in order to limit the risk of exposure of respirable dust, crystalline silica, aromatic hydrocarbon, xylene, and metal fumes chromium. So first and foremost, they must protect their respiratory. So they need to wear N95 face mask or chemical cartridge respirator. And for hand protection, they must wear barrier cream, physical or chemical resistant safety gloves. For leg protection, they must wear wearing the safety boots or safety shoes. For head and face protection, they must wear helmets, goggles, safety glasses, and face shield. And lastly, for body protection, they must wear apron or laboratory safety coat, protective shoes, and high visibility reflective vests.
In conclusion, the risk possibility of crystalline silica, xylene, and chromium vapor was determined using Nash method to find which compound is hazardous to worker. The 8-hour TWA of crystalline silica and chromium vapor were higher than their PEL, while xylene is below the PEL value. However, we determined that painting process contribute large amount of xylene substance at workplace. As you can see from the graph, for the employer test for compliance, UCL, the crystalline silica and chromium vapor were greater than 1, where there's no test needed for compliance and there's possible overexposure, while UCL xylene was below than 1, where test needed for compliance exposure. Next, the employer test for non-compliance LCL for crystalline silica and chromium vapor were also greater than 1, but test is needed, while LCL xylene was below than 1 and no test needed for non-compliance and there's possible overexposure.
That's all from us. Thank you.